Good evening, everyone. Today I'm going to present topic AFL Algorithm Test Input Selection and Scoring. AFL stands for American Fuzzy Loop, which is one of the most popular fuzzy testing tools used in cybersecurity and software testing. So the introduction to fuzzing. Fuzzing is an automated software testing technique where random or modified inputs are given to a program to identify crashes, bugs, and security vulnerabilities. So normally in case we'll be doing the manual testing, but in this case will automatically generates many inputs to discover unexpected behavior. Used in security and QA testing reduces manual testing effort. Next we'll see the type of fuzzing. There are mainly three types of fuzzing. Black box fuzzing works without knowing the internal code. White box fuzzing has full knowledge about the code. These will be doing the code testing as well. Gray box fuzzing, which often uses has partial knowledge and balances efficiency with accuracy. You see what is AFL? AFL means American Fuzzy Loop. It is developed by Michael Zaleski. It means different parts of the program are executed and trying to explore new paths to the code to find vulnerabilities. While widely used in vulnerability research. The working principle. AFL first tracks the program execution using instrumentation. It stores execution path in a coverage bitmap. Then it applies mutation on inputs and runs the program repeatedly. If new execution paths are found, those inputs are kept for further testing. AFL architecture. AFL carefully selects the best test case inputs instead of using random blindly. Inputs that explore a new program behavior are considered as valuable. This improves the efficiency and efficiency of testing and helps to discover hidden bugs faster. And it uses the mutation process. Mutation means modifying the input slightly. AFL performs operations such as bit flipping, inserting random characters, deleting bytes, and changing values. These mutations help generate new test cases automatically. Coverage gated fuzzing means this means that it checks fuzzing means AFL checks which parts of the codes are executed. If the new input reaches a new section of the program, AFL treats it as important and store it for future testing. Input queue management. It stores the interesting inputs only. It removes the redundant inputs and it maintains diversity in test cases. Ensures continuous exploration. This we have already covered the favored inputs. AFL gives scores to test cases based on how useful they are. Inputs that execute faster or explore new paths trigger unique behavior receive higher scores. High scoring inputs are mutated more frequently. So it figure out the favored inputs and it given more fuzzy guide. So the mutation techniques it follows are already covered. It covers bit flips, byte flips, arithmetic operations, and dictionary based mutation aspects. Energy assignment. Energy is equal to number of fuzz attempts. Higher energy will be given higher results or better inputs. It also, besides the fuzzing efforts, optimizes the resource usage. Scoring factors we have already covered, like scoring will be given based on the how useful scoring will be given to the test cases based on how useful they are, and the test cases which inputs that executes faster, it has more coverage and it has smaller deferred space and path depth will given more scoring. feedback loop. So this executes inputs, check for coverage bitmap. If a new path is found, save the input and that will be added to the queue and it will be continued. So what are the advantages of AFL? It is efficient, it is simple, fast, and it can automatically discover crashes vulnerabilities with minimal manual effort. It widely used in science, security research, and software quality assurance. The limitations are it may miss deep logical bugs because it's work only for sitting and it's work based on the random things. It may miss some logical issues in the code. It may struggle with highly with structured inputs, encrypted format, and programs require complex user interactions. It also depends heavily on good seed inputs. It's very heavily dependent on inputs. So based on the input, it decides the output. So if the input is not properly selected, the test cases and inputs it may fail. In real world scenario, it may be used in operating systems, browsers, network applications, embedded system. Many real world scenario bugs can be found using this. To conclude, the difference between traditional testing and the fuzzy AFL testing is that traditional testing requires manually designed test cases, but AFL automatically generates thousands of test cases and it makes very faster and more scalable for detecting hidden issues. And in many vulnerabilities in major applications such as web browsers or softwares were identified using AFL. This shows the importance of acid testing in cybersecurity. Also, AFL can be combined with machine learning and AI techniques to for the selection of the input and for the vulnerability detection. It is majorly used for gray box passing, gray box testing, and it is a great gray box passing tool. And it is based on intelligent input selection and scoring mechanism to discover software vulnerabilities.